Good morning, guys. Today we're going to be focusing on 4.5, solving polynomials. Now, examples 1, factoring, we've already done multiple times. Factor the polynomial, you find the zeros. If you need to practice that actual example, just go back in the book and practice. When they say finding the zeros, we graph the polynomial, and wherever the graph touches the x-axis or the x-intercept, those are the solutions. Now, what we're going to learn today, a new way to find the solutions is to use what's called the rational root theorem. Say, for example, they give us a polynomial like this. We can clearly see it's got no greatest common factor. It's not a difference of squares. We cannot use, it's not standard form. And if you try grouping, you're not going to end up with the exact, you can't group. It's impossible to group. So what we're going to do is, we're going to use what's called the rational root theorem to start breaking it down into factors and then see if we can factor normally any of the answers. Now, what is the rational root theorem? The rational root theorem tells me that the solutions are given from the division of the factors of the constant divided by the factors of the leading coefficient. Sounds confusing. It's not that confusing. Let's go over this particular example. Again, P is factors of 20 and Q factors of my leading term. Let's begin with my leading term. What number's there? 0. Malo. Remember, it's not 0. That's a 1. I can't see the number. It's a 1. So what are the factors of 1? Just 1. That's it. So I know that Q will always be 1. And it can be positive or negative. Always positive or negative. Now, what are the factors of 20? Remember, always begin with 1. Many students forget 1. 1 times 20. Then I go 2 times 10. 3, I can't. 4 times 5. 5 times 4. But I already have it here. So that means those are all my factors. So again, the solution will be either 1 divided by 1, positive negative 2 divided by 1, positive negative 4 divided by 1, positive negative 5 divided by 1, 10 or 20. Again, these are all possible solutions. They are not all solutions. They are the possible solutions. So how do I begin working? You always select the easiest value to work with, which is usually either 1 or negative 1. And I'm going to use the factor theorem or the remainder theorem. Actually, we're going to use the factor theorem that we learned to see which of these solutions or which of these divisions are the actual solutions. Again, remember the factor theorem. The factor theorem tells me if I synthetically divide by a number and I get an answer of 0, I'm looking at a factor. Entonces, again, let's write these possible solutions here so we don't forget them. Once you're writing down your possible solutions, you do not have to put the denominator 1. I was just putting it there so you guys can see that it's a 1. But my actual answers are positive, negative 1, 2, 4, 5, 10, 20. Now you're going to ask yourself, Profe, but that's like freaking 8 synthetic divisions. You don't have to do them all. You'll see. Again, if you practice and you work properly, you would not have to do them all. Let's begin with positive 1 and negative 1. See what happens. Let's begin with dividing by negative 1. Let's use this factor to see what happens. So I'm going to test to see whether this is going to be a factor. Synthetic division, I flip the sign. I put my coefficients. And now I'm going to synthetically divide. 1 plus 0 is 1, times 1 is 1, negative 7, negative 7, positive 4, 4, 24. Since I did not get a remainder of 0, I know that x minus 1 is not a factor. I move on to the next possible factor. Now let's try the factor x plus 1. See what happens. When I'm going to use x plus 1, synthetically divide, I flip the sign. And now I do my normal synthetic division again. I know it sounds long, but trust me, you will not have to test all the numbers. Begin adding. 1 plus 0 is 1. 1 times negative 1 is negative 1. I add negative 9. I multiply 9. I add 20. I multiply negative 20. I add 0. Magically, I know that x plus 1 is a factor. So I found my first factor. I'm going to write it down here. Now we're going to combine the factor theorem with another type of exercise we did yesterday that was list the answer as a product of factors. So now I'm going to write the answer also down here. Remember, since the original polynomial was of third degree, the first one will be second degree, first degree, constant, no remainder. Now let's carefully look at what I have right now. I have these factors. If you realize, you could continue doing synthetic division to find all the answers. And that would be correct, but it would not be efficient. But it would be correct. You might run out of time during the test, but you would be correct. So again, after you find one factor, which I already know that's correct 100%, I'm going to look at the answer I was given. And I'm going to review all factoring patterns to see if my answer can be factored properly now. If you realize this is an easily standard form problem. So two numbers that multiplied give me positive 20. And when I add those exact same two numbers, I get negative 9. The answer is x negative 4, x minus 5. When I multiply those two, I get positive 20. When I add those two, I get negative 9. Now, if you realize the solution to this factor is negative 1. I have negative 1 as one of my possible solutions. The answer to this one is positive 4, and you can confirm it is one of my possible solutions. And the answer here is, the solution here is positive 5. That is also one of my possible solutions. Again, if you can't remember factoring properly, which you should, as we've been going over the entire year, you could continue doing synthetic divisions with these numbers and you would get the correct answer. But before you get to 4 and 5, you'd have to do 2 synthetic divisions with the number 2, 1 more division with the number 4 that you don't have, 1 more possible division with the number 5 that you do have, and then you would be done. It would take you way longer. So again, factors of the constant divided by factors of the leading term, or the leading coefficient, sorry. Now, this particular problem is quite simple because all the factors of 20 were divided by the number 1. Tomorrow, we're going to be going over the exact same problem quickly with fractions, and then we're also going to have another class. So right now, let's stick to polynomials that have a leading coefficient of 1 and factors of 20. Now, before we continue, let's go over a couple of other examples, just so we know how to find this properly, PQ. If I were to tell you, list all possible solutions to this polynomial, again, my Q would be 1, so I don't have to actually put it. I just wanted you to see it before. So I know my Q is 1, so my possible solutions are the factor of this number, 16. I begin with number 1. I continue with number 2. I can't do it with 3. I go down to 4. And now I'm repeating my factors, so I stop. So my possible solutions are going to be either positive negative 1, positive negative 2, positive negative 4, positive negative 6, 8, and those are my and 16. Those are my possible solutions. Then I would synthetically divide using these numbers. Now, keep in mind that sometimes students get confused. Bueno, I plugged in the number 1, so is the factor positive 1 or is the factor negative 1? I can't remember. I always recommend you do it how I did the previous exercise. If your possible answers are these, I strongly suggest you write down the factor. I want to test this factor. I want to test that factor. And given this factor, you will synthetically divide properly. Change the sign of whatever's inside and divide here. Because again, believe me, students get confused. So I use the positive 1. But is that positive 1 my actual factor? Or is that the number I plug in here and it's flipped? There are a couple of systems you can use. For example, you should know that if you plug in a positive 1 here, because it's one of the possible solutions, the factor would obviously be x minus 1. But I repeat, even though it seems simple now, when we're working on just this one problem, when the test comes up, students freak out and they kind of forget. So again, just take it step by step and remember the process. If you're looking at this possible solution, I'm going to test this factor. Do my normal synthetic division with that factor. And if it happens to be a factor, you just copy it. And the answer you're given, you put it here and you continue the process until the polynomial is factored entirely. If you have any questions, please ask in the class forum. Remember to post your attendance. Remember to upload your homeworks before 10. Or, as the movie states, I see dead people. Let's go over the exercises you will do. You're going to do the following exercises. 25, 26, 29, and 30. Now, you have to do those 4 for the notebook correction. But you can just send me a picture of one page that you've worked on. You don't have to send me all the homework, but you have to do all the homework, because when I correct the notebook, I'm going to correct those 4 exercises, okay? But just show me, and I recommend you show me the last exercise, the last 2 exercises if possible, because they are slightly trickier. Have a great day. Any questions, chat, or class forum. Take care, guys. Boom.